Good morning. It's my favorite time of the week here with the undisputed hydro weight champion of the world, Harley Smith. I'm the organic
Hey there.
mechanic with Kelp4less.com. And we're just going to continue our talk from last week. We were discussing IPM and some preventative measures for, things that happen to almost all grower, indoor, outdoor, agriculture, big farm, small farm, all kinds of stuff. So very interesting ideas. And I know Harley has got some very unique kind of research data and things he's kind of just been poking around at that I think we're all excited for him to share with us. I know I am. I'm going to learn a lot from this. So I'm just going to turn it right over to Harley. IPM, PM, powdery mildew. What you got?
Okay. Well, prevention. I mean, once you're any disease, once you're fighting it, you've already lost. You're going to lose something. So, if you have PM and you're trying to get rid of it, it's, you can do it. You can stay on top of it, but it's kind of a race to harvest, in my opinion. If I start to see that, it's like, oh boy, I got to get there before I lose something more significant in the end. So that is no fun. But prevention is really important. And we get down to the number of my favorite element, if you can have a favorite essential element, calcium. Calcium is king. Calcium is the glue that glues the cell walls together. Calcium pectate and magnesium pectate, but mainly calcium. So it strengthens the stems, strengthens the leaves. Okay, so if you have good calcium uptake, then the plants are going to be more resistant to fungi and to diseases. So that's the most important thing. If you let's say you're growing in an environment that has high humidity, then that affects calcium uptake.
Like
So
most
not only are you,
greenhouses, most
yeah, most
greenhouses, pretty high
greenhouses,
humidity.
yeah,
Yeah.
and powdery mildew is even a little trickier because it's a combination of humidity and it can be even cooler temperatures. And that's where you typically see it when it's cool and humid more than hot and humid. But if the air is too humid, the plant won't transpire as much because the air is wet. It's going to not they're not it's not going to evaporate as well. Transpiration, and calcium is only taken up in the transpiration stream. So if anything that affects the environment that limits transpiration, you have the potential for a calcium deficiency, and that weakens the plant, especially plant cells to powdery mildew. Anything you can do to improve the uptake of water and minerals, the more resistant they're going to be.
So again,
So,
just because we use calcium and we add calcium and we know there's calcium in there, it could still not be available.
in fact, if you talk to some of my favorite plant scientists out there, they will. I mean, I've written articles about that, right? About calcium uptake. And they say, well, if you add CalMag, because you think it's going to help prevent it, so probably it won't make any difference because the calcium is going to get locked up. It's just going to be in the root zone. It's not going to get into the plant anyway. So number one is humidity, the relative humidity or vapor pressure deficit to keep that transpiration flowing, keep the calcium flowing, and air movement as well. And that's very, very important. It's often overlooked. In the indoor garden, you want to have at least have some oscillating fans, have enough air movement so the leaves are at least moving a little bit. You don't want a hurricane. You don't want blowing really hard on the leaves because then there's too much transpiration. It's blowing away so much of the moisture around the leaves that the plant can't take up enough water. And so the stomata start to close to conserve water, and then you have less transpiration. And then you can get calcium deficiency there too. So it can be looked. You want air movement, you want good relative humidity. Those two things are key. If you don't have the good environment, you're already asking for trouble.
Yeah, and for those viewers that don't understand the vapor pressure deficit, we've done a whole podcast, I believe, one of our early ones about the
Hmm.
pressure deficit. So they could go back and kind of review what you were talking about in a more larger term. I just wanted to throw that in as we move forward.
Yeah. In a nutshell, though, it's just the drying power of the air. The higher the VPD, the higher
Mhm,
the drying power, and that affects transpiration.
mhm.
We want to control that, especially a commercial greenhouse. But in a indoor garden where you don't go into that much control, air movement, so all the leaves are moving at least a little bit, and good relative humidity. And check the humidity at day and night. You have a min-max thermometer, hygrometer at the minimum, because sometime during the day, when plants are transpiring under the lights with the heat, there's going to be it's going to be lower humidity because it's warmer air. The air is able to hold more moisture at the warmer temperature. But then you turn the lights off, and that moist air starts to cool down. The relative humidity goes up, and there's less transpiration. So I like having air movement day and night. I like to at least know what my min max is for temperature and humidity, because maybe at night I might want to add a little heat if it gets a little too cold or the humidity goes up too much, just to keep things warm and keep the transpiration moving. Now the plants close their stomata at night, so there's not going to be a lot of transpiration, but you don't want to build up of moisture on the leaves overnight.
Okay, so step one, make sure you have calcium. Step two, make sure you have conditions to make it available.
Step three.
Environmental, a lot of big issue. Now, what's step three?
Step three is, to me, the most important thing of them all, and that is amino acids. And we've talked about this
Mhm.
more than one time. It's
Comes
because
up
it's one
every
of my
time.
favorite. Yeah,
Yeah,
it's one of my favorite subjects of the research
every
that I
time.
did.
Yeah.
Right, and some of the discoveries I made and applied. So it's just like near and dear to my heart. But two of the amino acids, do you remember what they are?
Boy, not off the top of my head.
Okay,
I'm
I'll
ashamed. I
remind
feel
you.
ashamed.
don't be, don't be ashamed. Glutamic acid and glycine. Of course, that's just technical why, but those two amino acids literally stimulate root cells to open calcium ion channels. So instead of one ion at a time being taken up into the root cell and then transported in the transpiration stream, the calcium ion channel is a voltage gate. It opens and then it allows hundreds or even thousands of calcium ions to come in. So if the plant's taking up more calcium through the roots and then taking it up in the transpiration stream, then it's going to start to build stronger cell walls. So instead of water in the interstitial space, you're going to have pectin, calcium pectate. So now, I've said this, I don't know how many times, one more time, doesn't hurt. If there's more calcium there, you have stronger cell walls and less water in the interstitial space. When a powdery mildew spore lands on the leaf, and that's going to, they're all over the place. We're not going to eliminate those, but it lands on the leaf, it doesn't germinate in the surface water. So you could literally rinse powdery mildew off the leaves. A lot of the growers do that. Or you can use a leaf wash to wash off the spores and kill the spores on the surface. But those aren't the problem. Spores on the surface. That spore wants to send out a germination tube to get to the water in the interstitial space in the leaf tissue. So once it gets into the leaf, then it becomes established inside the tissue. It's hard to kill it inside the tissue. And
Then you
then it
got
will
problems.
spread.
Yeah.
So the idea is you get more calcium uptake, then you're going to have stronger cell walls. So by the time that germination tube, whatever I forget what it's called, there's a technical word for that, but by the time it's able to penetrate the stronger cells and get to some water, it dries up and dies. So you're not killing powdery mildew. It's preventing the powdery mildew from getting established and spreading. And if you can do that, you win. Um, and I would like to bring
Yeah,
up
that's
one more
very
point
good.
with that.
Yeah, that's very good detailed information. And so that's a great description. And I'm excited to hear what's coming up next.
Okay. Well, I got two more things coming up. I hate to dominate the conversation here
No, this
because I
is
want to
good.
hear
We need this.
your input too. But there's another thing about calcium that is overlooked sometimes too. Yeah, the stronger cell walls, that's really good, really important. A physical barrier to powdery mildew prevention. But there's also a secondary effect. Calcium is what's called a secondary messenger. Okay, so what the plant takes up passively, it's taking up calcium. It's getting locked up in the cell walls along the way and in the leaf. But the excess calcium that's taken up, the plant will literally pump this calcium out of the cytoplasm. That's the liquid inside the cell. They'll pump out those calcium ions because it doesn't want them in there into the vacuole. And the vacuole is a storage compartment inside the cell. It's a very large organ. Um, so the calcium's in there. Some of it even crystallizes inside there as a storage for later on. Now, if the plant is under attack, let's say there's a hot spot in your greenhouse or in your grow room where powdery mildew was able to start to get it established in one little spot, the plant literally senses the chitin in the cell wall of the fungi. Plants don't have chitin, they have cellulose, carbohydrate. But the fungi cell walls have chitin. So do insects' exoskeletons, chitin. The plant literally senses the chitin. It knows it's under attack. It sends a signal molecule from the surface of the leaf to the vacuole. That storage compartment opens calcium ion channels in the cell membrane of the vacuole. And thousands or millions of calcium ions are released into the cytoplasm. And that calcium activates a series of enzymes. Uh, Calmodulin is one of the main ones, one of the first ones, that starts the process of an oxidative burst. And that's the first line of defense that the plant has against the fungi, the powdery mildew. So it starts that oxidative burst, first line of defense, boom, let's kill it right now. Let's let's bomb it. The plant does that naturally. And then afterwards, that, that after that initial burst, it triggers a series of enzymes that produce phytoalexins. And phytoalexins are the plant's natural antifungal agents. And it's also turns on, stimulates the immune system. We're under attack. Let's put all of our resources, let's put all of our energy into fighting this off. And if you already have strong plants with high bricks, they have the energy they need to do that burst, then you can get it, the plant itself can get it under control quickly. If it's overwhelmed, though, and you have a bad environment and a huge infection, the plant's not going to be able to catch up and beat it. So you see what I'm saying? I mean, we're building up an arsenal in the plant, a reserve. So if it's under attack, calcium triggers that reserve and activates all those enzymes.
That is a deep dive. I mean, you're getting way into it. That was, whew, that is some detailed info right now. I wish we could just see that with our naked eye. I wish we could see that happening, see that developing, and see all those processes that go on that we have no idea about. Again, those biological processes in the plant, those hormones, everything. Oh, it'd be nice to see that.
Yeah. And by the way, there's some microorganisms that fight fungus, not so much powdery mildew. But you can. I've heard of people using compost teas, spraying it on the leaves. Have you ever heard of this one? And it helps treat powdery mildew or help protect the plant against fungi. Have you ever heard of that?
Oh yeah, all the time, all the time.
Yeah,
Yeah, absolutely.
yeah.
Yeah.
Okay, here's the thing I was kind of saving because this is just something I've been thinking about. I'm not saying to do this. I'm not saying it's right or wrong. It's just something that I've been thinking about. I've been thinking about in the microbes they produce themselves. They produce an enzyme. Some of these plant protection ones against fungus, they produce an enzyme called chitinase that break down chitin in the cell walls of the fungus. They actually kind of digest it. They kind of penetrate it, and that makes the plant's natural fungicides, the phytoalexins, work more efficiently, or the other microorganisms, other antifungal agents work more effectively. The chitinase. So my thought was this: what if we were able to give the plants a boost by doing a foliar spray with chitinase, with that enzyme? Because it won't hurt the buds. It won't hurt trichomes. It won't hurt plants because plants don't have chitin. They have cellulose. But it would start to break down the cell walls of the fungus. So just a thought, just for food for thought, of a way to do a treatment, a spot treatment that is working in the same way as nature works for a natural fungicide.
Have you been experimenting with that?
Mm, I haven't.
No.
I haven't. I haven't tried it, but I always think of what's the mode of action, and I know that chitinase, like in trichoderma, it produces chitinase. There's some other microbes that are really good antifungal agents in the root zone. They produce chitinase, and they make other secondary metabolites, like the ones that plants make, and antibiotic or antifungal agents. But
Hmm.
chitinase, the chitin producers, I always thought it was being synergistic with the other ones. So just a thought that there may be a way to incorporate that into a spray. The other one, I guess you can go into this too, but fungus in general doesn't like alkaline conditions. So if you can do a spray that's a little bit more like 8.2, 8.4 up in that area, that's not conducive to fungi. So, that's why a lot of times they'll use some simple things like potassium bicarbonate.
Bicarbonate. Yeah,
Yeah, they
bicarbonate.
use that
And
because the pH is higher and so forth. Go
right,
ahead.
right. And a lot of our customers, they talk about this all the time. I've personally not done this, but they do foliar applications with raw milk. Uh,
Yeah.
as an outdoor fungicide. And I could just never bring myself to do that because I get this nice container of raw milk. I'm going to chug it before I spray it on my plants. So it's never worked for me because it always disappears before I can get it to the plant. But we have a lot of customers that do that. And so, that's just an old cultural practice that still carries over to this day. Can you explain to us why that how that works for those? I'm not going to say it's a fungicide, but I'm going to say, how does that work to help protect the plant from fungus?
I don't really, I don't know. I don't know if anybody knows for sure. I haven't seen any data on that. I've kind of wondering though if you might have um, some of the breakdown of that. Like there's a whey portion in the milk, not much because that's really a waste product of cheese making, but it's in there, and maybe that's actually made into amino acids. For one, I know the milk is high in calcium, isn't it?
Yeah,
Relatively high.
yep.
Yeah.
Calcium
So
lactate.
maybe there's some things going on there that are just with the microbes that are on the surface of the leaves that are starting to break down some of those larger molecules. Maybe they're making some other beneficial things in the process, but I don't know. I,
Yeah,
that's just a guess off the top of my
yeah.
head.
If some of our viewers out there um, can chime in and send some comments on our way of, things that they've learned and known about it. Just interesting. Be like to hear what some people have to say. And speaking of raw milk and dairy, how I may be invited to do a presentation in Green Bay, Wisconsin,
Hmm.
and that's quite a bit a drive for you, isn't it, from where you're located? That's quite the trip.
It's a pretty good one because it's not that far away. I mean, it's the next state over. If you go right across the lake, but
Hmm.
the drive you have to go through Chicago area. You go
Oh
down through
yeah.
Chicago and up, and it's like, oh my, it's sometimes it's a nightmare when you're not used to that kind of traffic and
Well,
back up.
when I'm that close, maybe I'll just hop on a little flight, come over and see you.
Oh, wow, that'd be cool.
Yeah,
Yeah, just do
yeah,
a little puddle jumper across the
yeah.
Grand Rapids or something and come pick you up.
Literally puddle jumper over the big puddle.
Just over that. Yeah, but it's a short trip, but it's a long way by car. You would not want to drive that
Yeah,
just to
yeah.
go out to lunch. You know,
Well, good. Um, I think we covered a lot of information. Boy, some of that was way detailed. I'm gonna have to re-watch this quite a few times just to fully understand and just let it sink in what you're talking about. But boy, that's an amazing mechanism that goes on inside the cells of a plant. That's unbelievable.
yeah. I think there's actually a microbe too that's Streptomyces lyticus that used to be. I don't know if it's the same one. Maybe they have a different one now for whatever reason. But that used to be in a product that they used to as a foliar spray against powdery mildew. And again, the microbes are making some of these enzymes and also doing some triggering some defense systems in the plant, and that may be why it's working. And I'm going to talk to you to later too about there's a microbe that literally will break down pesticides in the soil, and it feeds on a lot uh, a lot of different organic compounds, even toluene and oils and things like that. I will talk about that later too. If somebody wants to try to remediate their soil, they want to try to help the some of those residual herbicides and fungicides and stuff to break down more quickly. Nature has a way to do that too.
Oh
We can talk
boy.
about that in the
Yeah,
future.
we need to pull you in on this. I'm in a pretty big project right now with a lot of influential people that are, trying to get a program together affordable for that exact same thing on a large scale in agriculture. So, oh yeah, that'll be a great discussion. And I continue to learn more and more about that every day. But the residuals of synthetic compounds in our soils is a big deal. Um,
Yeah,
they're not going away. A lot of them are bound to organic matter, and they get released when that organic matter gets decomposed and gets back into our food system, our crop system. So, yeah, there's some neat things ahead on doing that, just
yeah,
cleaning the soil of some of those compounds. So, oh yeah,
yeah.
now that's right up my alley.
And that might be a good topic for a future podcast too, is the role of using mushrooms too that help to do bioremediation of soils and some things that we can do just to we want to create healthy soil. We know both of us know how to do that, and you know it better than I do. But we might have to remediate some soils that weren't taken care of very well in the past.
Yeah, I can't wait. That'll be a good one.
Okay. Well, I think we've covered PM for the time being. I'm sure we missed a lot, but the viewers out there may send us some other suggestions we can bring up later.
Yeah, and great information. No matter how you slice it or how you lay it out, that was some good info. We appreciate your time. Looking forward to next week already.
Okay. See you next time. Have a good one.
Okay, give Sue my best.
Ah, okay. See you
All
later.
right,
Oh, wait a minute.
all
Wait,
right.
wait.
Bye. Oh,
When are you going to Green Bay?
it'll probably be in the late springtime.
Oh,
The
okay.
late springtime. Yeah.
Plenty of time to plan. Okay. Talk to you later.
Okay. See ya.
Bye.
Bye.